Oh, perhaps a couple of notes here, Salty. Now, again, this is the black hole, man. This right here is getting it started. The first dot equals Feynman that gets you going. But essentially, you got some angle problems, right? And it's going to come inside of here. I could start highway this way, I could start low way this way, and they're definitely different from each other, yet they share a lot of the same geometries here. Dot and a neutron, really. A proton, a neutron, a proton where the angular gives me some weird clicking, clanging, shooting at this thing. Well, they're all the first square, right? That's the kind of the point with this about hydrogen, helium, and Bohr model. But anyway, we'll get to the charts in the gap here in a minute later. As far as what Pauly says doesn't exist if you hit it hard enough or you're not calibrated anywhere close enough to what we'll be getting into it, yeah. But basically, you got a dot, you got this what is a proton and a neutron, and the electron inside there. So you get these ion states. Essentially, play with me. And in fluid dynamics, you can only get so close, right? That's where all the Brownian mechanics, the teleporter on the Starcraft or Starship Enterprise starts to break down about the ones and the zeros on that gap. It's going to want to jump at electricity. Lots of ones and zeros in there. This thing goes down probably smaller than 10 to the 120th, or excuse me, smaller than 10 to the negative 33rd. But that is what we can visibly see. That's what we can kind of quantify in the square law here, or what have you. But essentially, when we stay in the same brick here for dimensions, basically that's saying it's an equal force and an equal force. Where it could be high or low like that, and if it is, it's going to be that this is a blue hypermassive giant, and then this would be what would be amountable to our star, or some planetary nebula base of it's running into that, picking up gas. So you got to consider that fluffiness inside of, well, where are we? Yeah, here, inside of like what it is. Because essentially this is all butterfly spectrum, right? When we get into what it actually does, if you take my garden books out, I'll put all that together in a little bit and I'll keep it on my line, but I'll take my other 3x3s I got out for it, and I'll show you the Pangea ones in a book already. I already got the Mavliconian tilt, but I don't really have one about the tidal forces on the planetary model that's good like this yet, so you don't get that yet, right? You don't get that point for your score, because for sure you understand it. There's no other way. Okay, so basically you get these heavy pure gas states. Earliest of the universe is that red massive black hole that's way out there on James Webb's, right? That's as far back as we could stretch it. Hydrogen hasn't even, just kind of bloop into universe out of whatever was down there below 10 to the negative 33rd, right? Okay, fair enough. They got some walls, some periods, some odds where some stuff is happening. Either that little bitty stuff that pops into the neutron-proton version of that when you're doing this, because of the way that collides, it could have fractaled. If it did fractal, is it in halves and thirds? Is that a flake? Does that flake have symmetry that's x1 and x, or x and x prime away from each other from y? Right, because here you can't really, it's just colors and then data. So if we're going to go to the data, we got to go to the arrays, right? This bracketed set, something much like this, but again, here towards, well, knowing that, it was a reverse engineering, I didn't build some survival game engine. What I had instead of an option was the ability to say the job was burning bluestone. That's the main key. They were every 10-minute checks inside of here in terms of the increment, so 1 hour is like 100 and, well, that's on 2 by this scale, but base to height. What it's actually doing is to say this new unit, or by quarters inside here, is the 10-minute check. And it's not 15 minutes, but that would have to correlate to more fine fractal derivatives inside of there, but I only had limited space, right? And I wanted to get it up to 0 from the A, so we have something to start with of its last step of building multiple steps and comparing data, and even being able to arguably say that these all units are the same unit by day, right? It's not going to Fibonacci truly like that if I'm burning calories and wearing a ball cap, goggles, mask, and earmuffs. It's certainly not just your straight steel toe. It's not just your straight blue jeans. It's not just your frost grip gloves, which is the trade base inside of there, but gloves might be what you get. And so when you're getting into all that about what these differences are inside of here, between hydrogen and helium, or hydrogen in the first ion state or the second ion state, from what that is the full derivative away from it. Pauli says this doesn't really exist because it'll either do this or it's going to break down again and do something of that effect, right? That's the lowest level integral you can, the L, the base, low, and the high. The shortest distance is 1, or the radial of 0, or the diameter of 0, excuse me, here. The half function plays here, rise over run for your strategy or your portfolio. This pie chart that says here it's going to be hydrogen and helium. Very early universe, super pure, maybe some protium and some prior minus things there. But essentially, I'm still taking that model and I am breaking it down in a very specific matrix function with scalars and vectors. And scalars are fancy ways to say vectors. And you can't necessarily do them in order because of some of the problems with the geometry, right? Do you start with the triangle? Do you start with the circle? Because there's nothing, it's a circle. Here there's extra parts, and there's 4 of them, but 2 are the same, and all these 3 are individual but different and can have any length or shape, which, given certain collisions or flaking or just torsion that makes it rip itself apart, that crystalline structure has a lot of types of forces, if you will. That's, from the backside coming in on scale. What's it going to do? It's going to impart some force on the core. Is it going to make it all the way to the core? Well, is it pure like the early state of the universe where something like that happened? Maybe it's in itself a thing. Maybe there are other ones. Maybe there's a field between them that creates some of those models across the board. And when you take that from a variance of scale, well, you'll have things that are going to be this chaos symbol in terms of what this red giant, supergiant would be, the phase after this, in terms of some of this monster where I'm saying the negative portions to the black hole, specifically these two, are not on the scale of R star in the way I'm playing this game in a field relative to how much time we put while I'm taking a case study to understand this. If, again, you take the Python models of Google Sheets here and you say, well, the app script, I want it to only give me certain rows and columns, and I'm going to compare them in certain models to get a certain game board or result out of what you're trying to accomplish. Well, Goku, I mean, this is what it is.